Hello, geometry students. Today we're going to begin a two-day segment where we switch gears a little bit and start looking at the other calculation that is involved with three-dimensional solids, and that would be volume. So please copy down your title, Volume of Solids, as well as today's objective, which is to learn to calculate the volume of prisms. As always, anytime you need more time to copy something down, press pause and then hit play when you're ready to move forward. So let's get started. First thing we need is a basic definition for volume, and once again, my highly technical definition here. The volume is the amount of stuff required to fill a solid. Now, as always, the stuff is the units of measure. Okay, inches, centimeters, kilometers, whatever it is. Okay, volume is the internal part of the solid. As I said in class, I tend to think of like a present when you're dealing with solids. Surface area would be the wrapping paper. Volume is the gift itself. Now, many of the solids that we're going to be looking at, or that we have been looking at, they do have a generic formula that goes along with them when it comes down to finding volume. That's going to be true for both the prisms today and the pyramids on the next one. Okay, but the formula is written in a very generic form, which means it's going to be up to us to make the formula fit the particular solid that we're actually looking at. So here is the formula. The volume of a prism is found by big B, little h. Now, we've seen these variables before. Hopefully we remember big B refers to the area of the base, and h, as always, refers to the height of the prism. Okay, and remember that height does not necessarily have to do with how tall something is. It deals with the distance between the two bases. Now, of course, big B, area of the base, that area is going to depend upon what type of shape our base actually is. So we will have to adjust this formula depending on the prism that we're looking at. Okay, so let's take a look at some. Find the volume of the rectangular prism shown below. Now, a lot of people prefer volume calculations rather than surface area calculations, especially where the prisms are concerned. We no longer have any need to unfold the prism and look at the net. The formula simply does not work that way. Okay, so all we have to do is make our formula fit our solid. So volume equals big B, little h. Okay, so we're going to identify what type of a shape our base is so that we can apply the correct formula, and then we'll figure out the height. Well, one of the unique things for a rectangle, okay, of course, a rectangular prism, is that, of course, the base is a rectangle, so we have base times height. Now, one of the thing with a rectangular prism is it doesn't actually matter which side we call the base, because, I mean, if you remember, the definition for bases in a prism is that bases are opposite, parallel, congruent sides, and there will be two of them. Well, in the case of a rectangular prism, we could call the top and the bottom the bases because they are opposite, parallel, and congruent. Same would be true for the left and the right side. They are opposite, parallel, and congruent. Front and back, same deal, opposite, parallel, and congruent. So it's completely up to you which pair of sides you would like to call the bases in the event of a rectangular prism. Typically, I just usually think of the top and the bottom as the bases for a rectangular prism, since that's just the easiest way for me to get it through. But do as you will. So in this case, I'm going to say that my bases are the top and the bottom for the rectangular prism, and the measurements of the rectangle on the top and the bottom are 4 and 3. So of course 4 by 3 is 12. Okay, so there is big B. Now let's get little h. Okay, little h stands for height, but remember, height does not necessarily mean up and down. It means the distance in between wherever your bases are. Okay, so in the case of this rectangular prism, if I am calling the top and the bottom the bases, then how far is it between them? Well, clearly marked in the picture, 2 inches in between them. So an easy measurement there. And now all we have to do is fill in the blanks in our formula. Volume equals big B little h. Well, on the last screen, we said that the big B calculation, area of the base, was 12, and we discovered that little h was 2. 12 by 2 is 24. Now keep in mind that volume is a three-dimensional measurement. It has length, it has width, and it has height. So that makes this calculation in the third dimension. So anytime you answer a volume question, you will put whatever your units of measure are, in this case inches, and it will be third dimensional, cubic inches. Okay, let's look at a shape that's not quite as simple. Okay, this time we have a triangular prism. Obviously, the shape of the base has changed, but the formula does not. The volume of a prism is found by volume equals big B little h. So all we need to do is identify what type of shape our base is, apply the correct formula to go along with that base, and start plugging numbers into our formula. Okay, so what kind of a shape is the base? Well, our bases are triangles. If you couldn't tell that from the picture, surely you can tell that from the problem, because it does identify it as being a triangular prism. Okay, so the formula for the area of a triangle is 1/2 times base times height. Okay, now keep in mind that this is referring to the base itself, not to the prism. Okay, so this h that you're looking at in this formula is not the same h that goes in the volume formula. Okay, that's an important part, and it's something that some students have trouble with. Okay, so let's look at our triangular base and see if we can tell the base and the height of our base. Now remember that base and height are measurements that are perpendicular to each other. So looking at the triangular base, do we know the two measurements that are perpendicular to each other? Yes, we do. They are the 3 and the 4, straight out of the picture in this case. Okay, so 1/2 times 4 times 3, that is going to be 6. Okay, so there is our big B value. The next thing for us to do will be determine what is the h of the prism. Okay, so how far is it between the bases? Well, let's look back at the diagram real quick and see if we can tell how far is it going to be between the triangles. Okay, well, this one you can't think of height as being straight up and down, because it's absolutely not. One of our triangular bases appears to be kind of on the front side of this figure, and the other triangular base would be hiding behind the back side of the figure. That 5 meters that's back there is the hypotenuse of the other triangular base. Okay, so how far are those two triangles apart? Reading from the picture, they would be 6 meters apart. Okay, so it will be a 6 in this case for h. And then all we have to do is plug into our formula. Volume equals the area of the base times the height of the prism. We already found that the area of the base was a 6, and the height of the prism also happens to be a 6. And 6 times 6 is 36. And again, this is a volume calculation, so our answer is in the third dimension, 36 cubic meters. It's always possible that our prism may be a cylinder, might have circular bases. Doesn't change anything except for the type of formula that we use for the area of the base. However, a cylinder is a prism, and the volume of a prism is found by big B little h. Okay, so you ask yourself the same series of questions. What type of a shape is your base? It's a circle. And what type do we have a formula that goes along with the finding the area of a circle? Well, of course we do. It's pi r squared. So all we have to do is plug the proper radius into this formula, and our radius in this case will be a 4. Okay. And again, I do not mind on these calculations if you go ahead and convert pi into a decimal point. Just please remember you do not round off decimal points until you get to the answer. Okay, we don't round off in the middle of a calculation and then round off the answer as well. You only round off one time when calculating a problem, and that is at the end of the problem. Anyway, 4 squared is 16, and then if you multiply by pi, you end up with 50.27. Now, I have rounded off for the purposes of putting this number on the screen, okay, but you would want to hold on to this decimal point in your calculator and not lose the decimal points that come after 0.2, whatever that was. Okay, looking at h, we need to know how far is it between the two circular bases. Well, looking back at the diagram, once again, it was provided for us. If it wasn't provided, we would use one of our old tricks, build a right triangle somewhere and see if we couldn't use Pythagorean theorem or something to help us find it. But in this case, the two circular bases are obviously 10 feet apart from each other, so h is 10. Okay. Taking information, plugging it into our formula here, our base was 50.27 and all of the decimal points that went along with that. And then our height is 10. Well, that multiplying by 10 is just going to move the decimal point over one spot. Okay, so 502.7. Okay, the actual decimal points hanging on to the end of that problem would not have changed much because multiplying by 10 just moves the decimal over one spot. And we're calculating volume, so our answer is in the third dimension, 502.7 cubic feet. Now, I believe you've probably got the hang of it here and probably do not need to see another example, but I do want to show you one more just because it is a special case, so copy this one down as well. Let's say the rectangular prism, or the prism just in general that we are asked to find the volume of, happens to be a cube. Well, something a little bit special happens with this guy, and that's why we're taking a little moment to look at it. But again, it is still a prism, so its volume formula is big B, little h, just like all of the others. Okay. The difference here is the fact that all of the sides, all of the faces of a cube are squares. Okay, so when you go to multiply, or you figure out which side your base is going to be, and with a cube it won't matter. Okay, the area of that square is going to be found by side squared. And then you're going to multiply that times its height, which is also the same as the length of S, side. So you end up with side squared times side. Okay, so you actually have side times side times side. And an easier way of writing that formula and an easier way of understanding that formula is the volume equals side cubed. Okay, now keep in mind, to cube a number means to multiply that number times itself 3 times. That's what an exponent does. Multiply by that number however many times the exponent says. So all we need to have in order to figure out the volume of a cube is what is S, what is a side length. So all we're looking for is any edge that is in the figure, and we have one, 9. Okay, 9 cubed. 9 times 9 times 9 is going to be 729 cubic millimeters. Okay, so as you can see, volume calculations are not really that difficult. They may remove a particular measurement that you need from the picture in order to plug into the formula. But again, that's where we set up right triangles to target our missing measurement. Okay, we can run it through Pythagorean theorem or SOHCAHTOA or 30, 60, 90s or 45, 45, 90s. We got a lot of little tools that we can help us to figure out missing information in a solid so that we can plug into our formula and finish the job. Anyway, I appreciate you finding time to get your notes taken care of, and I'll see you in class.